Welcome back to our series of lectures on textile finishing. Like last time we said, although we will be correlating various aspects of chemistry of the chemicals and the chemistry of the fibers, but we shall not be mentioning every time, but we will use whenever we need to, and that is an important aspect in any case. Let us look back as to what we have done. We have understood that the N-methanol compounds can be used for producing wrinkle resistant cotton viscose fabrics, that is, these fabrics based on cellulosic material. And some of the agents, the names that have been used, the chemicals that have been used are DMU, DMEU and DMDHEU. I had asked you to look at some other chemicals also. I hope you have had time to look into those chemicals as well. Also, we learned that the reaction with these N-methanol compounds and hydroxyl groups of cellulosic material is an acid catalyzed mechanism via carbonium ion formation. The process which we said is more suitable to finishing, particularly wrinkle resist finishing, is a pad dry cure process. This is an important process and which we believe will always give you a smooth surface. We also learned that the machine that we actually rely on other than a mangle is the stenter, which can control the dimension of the fabric which is being finished. We also try to argue why should we go for a pad dry cure process and not simply a pad cure process, because curing is obviously done at a higher temperature and the drying obviously can take place at this temperature as well. Remember what we said? We said there can be non-uniform treatment, and why? It is because we can have migration of chemicals across the material where there will be tendency to move out along with the water which is being evaporated. That is, the rate of evaporation of water, if it is very high, which will be sure if the temperature difference is high, that means curing temperature is high, 150 degrees centigrade for example, and the fabric entering is at room temperature, so difference is pretty high. So, rate of evaporation will be high, and at that rate of evaporation the chemicals can also move out along with the water. Water will evaporate, but the concentration of chemicals around the surface will be higher than, let us say, in the bulk. You remember we said cross-linking should be uniform, and what it means is if we consider as a wrinkle recovery as a finish, this is a change in the bulk property, not a surface property. So, we are changing the whole fiber, the yarn and the fabric, obviously at a molecular level, but we must penetrate, we must ensure diffusion, uniform diffusion of the chemicals across whole fiber and the yarn and the fabric. Now, we take this discussion a little further. So, we are preparing a fabric which is wrinkle resistant. There must be some way to measure the performance of this fabric, and this is what we will try to highlight more in this lecture. The performance of these fabrics, sometimes also known as wash and wear fabrics, can be done by measuring crease recovery, bending length, strength, tensile strength, abrasion resistance. The important thing of course for us is crease recovery, because only the motivation for us was basically to improve this recovery properties, by this cross linking. So that is of course important. We know how to measure. What would be, let us say, the effect of add-on? Add-on, let us say I am using DM, DH, EU. How much, what percentage of this chemical has actually been added on to the fabric? This is an important information which we may like to know. How can this be done? Well, this can be done by taking initial weight of the fabric, if correctly taken, and then after padding, drying, curing, we take the final weight, hoping the reaction is 100%, then we will be able to see how much chemical has been added. You must remember, I hope you remember already, that there is a difference between content and add-on. Okay? If somebody says the chemical is 2% of the weight is a particular chemical in a fabric, then it means 98 plus 2 in 100. But if somebody says 2% is add-on, so what we mean is 100 is the fabric and 2 is the chemical that we have added, right. So, this is how one would be able to understand the difference between the add-on. Let us say we are talking about add-on. If you increase the add-on, then what do we expect would happen to crease recovery? What will happen to crease recovery? Crease recovery should increase, all right. So, let us say in general, if we try to plot the add-on versus crease recovery, you remember how crease recovery is measured? Crease recovery is measured as a recovery angle of warp plus weft, right. So, this should increase. So, generally we believe that will increase, but if you keep on increasing, you cannot, hopefully you may get some kind of saturation value and the rate of increase may be less. But generally we expect that there will be increase. It may or may not be linear over the whole range of add-on, but that is what we will measure. So, how much crease recovery you want will also depend on what kind of a material that you want. If you want very highly durable press type of a material, then we may want to have crease recovery angles more than 300 degrees. Right? And if we are looking at a wash and wear, maybe we are around 280 degrees How much can be the maximum crease recovery angle if everything is the best? How much maximum? It can't be, it can be maximum 360 degrees, right? 360 degrees. So, when we increase the add-on, that means we have added more chemical by the padding process, drying and curing of course, and then you get more crease recovery. Obviously, somebody will limit this. Then this term that we talked about just before, wash and wear, this was the term which was coined in the early days when the grease resistant finishing was thought about. What it meant was, don't worry about anything, take a garment, wear it, wash it, and then without ironing, wear. So, very good concept, but the only thing which people found was that after a few washes, the fabric does not appear to be as smooth, and you may have to iron. And therefore, generally saying, well, it is a wash and wear type of finish, it may not really be true to these sentiments, and therefore, people talked about the effect, how much is the effect which remains after washing. And so, instead of saying wash and wear, we said wrinkle resist. So, it is resisting the wrinkling process and not completely a material which can be just washed and worn. Okay. So, that is a kind of a difference, and therefore, people talked about other ratings also. The other rating which people use, when you sell anything to the client, they may like to know, is DP rating. DP means durable press. So, what does it have? So, durable press rating is a appearance of a fabric after you have washed. So, normally I said it is a final finish. So, the fabric may not have been obviously washed, or even if it is washed, maybe another process would have been given, like a calendaring process. So, it is a smooth surface which you get, but when you wash, what happens to the appearance? That is something people want to determine. Some people will say, well, I have given one wash, but a fabric is going to last more than one wash, and so we would like to see how this appearance changes. Let us say after 5 washes. Which kind of washes? The washes could be hand wash, the wash could be machine wash, but then you would like to see. So, that would depend on a client. For example, we will tell, well, we would like to see your DP rating after, let us say, X number of washes, and we will then buy your fabric or not buy your fabric. So, that is the limitation that somebody can put. So, how do we measure? How do we measure the appearance? The appearance is measured by a set of plastic replicas. Replicas is like you take a photograph. Some wise people, obviously the people who decide standards, and we agree to those standards. They look at which fabric wrinkles more, which fabric wrinkles less after washing, and then based on some gradation, they have agreed to say a certain set of grades and certain set of appearances, and you made replicas in plastic that this is how a fabric is going to appear after wash. So, you have replicas, then people compare with the replica. It is like you could actually have a photograph also, or you can have plastic replicas. So, you compare as to how your fabric, which is you have treated, versus a standard which should have been, where does it fall? And then you assign a number. So, these days, like you assign a number in wash fastness from 1 to 5. Here also you give a number, numerical value from 1 to 5, 5 being the best and 1 not being the poor. That is how one would look at it. So, various standards organizations like AATCC or ASTM, or in Indian situation BIS, all of them have their standards defined as to this is how the replicas are there, this is how the photographs are there, and you compare with them. And of course, they decide on the process as to how and which process must be followed, so that there is some standardization which you can communicate properly with your client. For example, one of the standards is AATCC Test Method 124. So, this is a method which talks about how to cut your samples, how to wash the samples, what conditions you to wash the samples, depends on how many number of cycles that you want, you can that can be specified, and then after that you compare with the standard replicas. So, this test method therefore talks about standard from 1 to 5, but in between also they have put another value 3.5, that is they have decided. So, you follow. So, obviously, SA is smooth appearance. If you appears very smooth after laundering, it will be called SA5. So, it would be classified or characterized by, let us say, very smooth appearance like a pressed garment itself, and very finished kind of appearance. The SA4 is slightly less, that it does not appear to be pressed, but still smooth, not very smooth. In between you have fairly smooth, but non-pressed appearance. So, you will say, well, nobody has ironed this, but okay, it is smooth enough. SA3 is mused, it looks like as if somebody has crushed a bit, used, and non-pressed appearance. 2 is rumpled, and 1 is actually creased and severely wrinkled. If this is the kind of appearance that you have, people will give these kind of ratings. So, this rating can be given after first wash, it can be given after 5th wash, it can be given after 10th wash, based on the requirement of the client also. And so, one can say, well, after so many washes, this is the rating. Some people would obviously be interested to know this, all right. So, this is one way in which one can look at the fabric's performance as far as the wrinkle recovery is concerned. And then what do we do? Is there any other way you can measure? Well, you can measure by again washing, and instead of going for a wrinkle recovery, you can also see the durability, in the sense that you just look at the crease recovery angle again, do 5 washes, look at the crease recovery angle. This will be something which people will be able to identify and say, well, the crease recovery has reduced, and so we may accept, we may not accept the performance. Why would the crease recovery reduce after washing? Why would the crease recovery reduce after washing? It can reduce because there can be hydrolysis, and some of the crosslinks can break. You remember the fishy odor? If the fishy odor keeps coming, that means some of the crosslinks are also being broken, and because they are being broken, so the performance can obviously go down. What else can be tested? Crease recovery of course is the most important one, no doubt about it. But let us see what else can be tested. One thing that can be tested is bending length. Okay. Bending length can be tested by taking a strip of fabric, again based on the standards. Let us say this is the fabric, and there is a scale So, initially you may have a situation, the platform, the fabric and the scale are aligned, and then the combination of, because there is a friction between the two, when you move this out, the fabric also moves out like this. The fabric also moves out like this, and at a defined plane, after some time it may touch as you are moving out. So, when you move this, how much is the length? Before this edge of this fabric touches this thing. So, you can appreciate if the fabric is very rigid, very rigid fabric, then you will have this length, you will have to move it much more before it can touch this. If it is flexible, then it can touch maybe here. So, length can be less. So, what it means is the bending length is a measure of stiffness of any fabric. So, what would happen to the fabric after our cross-linking treatment, wrinkle resist finishing treatment? What do you think? The bending length would increase or bending length would decrease? Or you can answer the other way, is it the fabric going to become softer or the fabric is going to become stiffer? What do you think? The fabric is going to become stiff. Why would it become stiff? It will become stiff because you have created intermolecular resistances by introducing covalent bonds which are strong. So, they will resist any bending. The stiffness normally is reflected in the bending properties. So, bending length is one of them. So, after cross-linking one can expect that the fabric may become stiffer. Now, you have to define how much stiffness is acceptable. Based on that you would say how much add-on should be there, and so one would consider this an important property. So, fabric will become strength and the bending length would increase, right or no? Yes, bending length would increase. What about tensile strength? How do we measure tensile strength? Well, you can have some tensile testing equipment which may have jaws. You can grip your fabric in the jaws and then increase the distance till it breaks, and then one can see and measure the tensile strength. The tensile strength of fabric or a tensile strength of a yarn or a fiber, they are measured in different ways which have been already defined. I am sure you would have gone through some procedure to measure the tensile strength of a fabric. what would be the effect of cross-linking on the tensile strength? So, we have done the cross-linking. When we have seen the crease recovery has improved, we are happy about it. The bending length has increased, we may not be so happy about it, depends, but normally an increase in stiffness may not be desirable after every finishing treatment. So, next is whether anything happens to the tensile strength. So, what have we done? You have fibers, you have molecules in the fibers which have been cross-linked. So, after the cross-linking, and now you want to give them a tensile load, and the cross-links that have been formed are obviously covalent bonds, stronger bonds. So, what do you normally expect would happen if we do such kind of linkages in any molecular structure, intermolecular cross links? What will they do? We understood they will make the material stiffer, bending will be more difficult. You remember we talked about resiliency, resistance to deformation is one part of resiliency, other was recovery from deformation. Because these bonds are stronger, so they resist, that is the stiffness. So, that has increased. Now, what happens to tensile strength? What would happen? So, before we answer this question, we should also try to find out what type of factors, what conditions actually are being used for processing. One important thing we know is that during curing, we do increase the temperature. We said the temperature could be increased from 120 to 150 or 160 depending upon the reactivity, the GSM of the fabric and the time that you give for completion of reaction. So, curing temperature. So, one, we are obviously interested in completion of a reaction, but during this process the fabric is also being subjected to higher temperature. What effect the temperatures could have? Have you seen any fabric put in an oven for some time and what happens? See the color? What color do you see after little exposure? It starts becoming a little yellow, then become brown. If you do bad job, then obviously it will become black. Char. But obviously we are not going to that kind of a temperatures in that kind of time. But still, heat is one of the things which will definitely, if not properly controlled, would lead to some deterioration of properties. If deterioration property means what? Tensile strength can go down. Tensile strength can go down, and that is why this is one important factor. People would always like, can I complete this process at a temperature which is shorter, lesser, instead of 150, can I complete in 130, can I complete in 140? If you can reduce the optimum temperature by 10 degrees, you will find as far as the strength and other properties are concerned are going to be better. But then we are now have a situation, we have to complete a chemical reaction versus we have to also worry about the tensile properties or deterioration of the fabric itself. The other important thing that we have to remember is this reaction is acid catalyzed reaction. Okay? Do you remember that? Acid catalyzed reaction. Because it is an acid catalyzed reaction, therefore, the degradation can happen from the acid. I am not sure if you remember, if you put a concentrated sulfuric acid on a cotton fabric, what happens? There will be a hole. Even if you have dilute sulfuric acid on a fabric, it does not dissolve on a cotton fabric we are talking about, but when you dry, the water goes. So, what happens to the concentration of acid on the fabric? It increases, and so it can deteriorate. That means, acids can deteriorate the cotton cellulose, right. If this happens, then obviously tensile strength, what will happen to the tensile strength? It will go down again. So, you have reasons to believe the curing temperature and the acid at that temperature, along with that it is becoming little concentrated, can have a deteriorating effect. So, one would say, well, low temperature or low time, this is how we will optimize. So, you do not really have to optimize only the crease recovery, you have to worry about the tensile strength, you have to worry about the bending length, all of them are part of a thing. So, crease recovery is of course the most important performance characteristic that you like to make. Then of course, we are doing the cross linking itself. So, cross linking, what will be the effect of cross linking? Acid is deteriorating, temperature is deteriorating. What about cross link? The cross link in general is a common sense said, well, it can make a material stronger, right. You believe so? So, let us see something interesting. Effect of cross linking on tenacity. Tenacity of fabrics made from cotton or fabrics made from viscose. People found that this effect is different. Do you remember what happens to the tenacity of cotton fibers, yarns, fabrics in wet condition compared to a dry condition? You may have been told that in the mills people keep little high humidity environment during processing and mechanical processing of fibers and yarns. You may have been told that the tenacity of cotton, wet tenacity of cotton is high or is higher than dry. The wet strength of cotton is higher. What about viscose? It has always been seen that the wet tenacity or strength is lower. So, that is the wet. So, this is an interesting paradox. The wet tenacity of cotton is higher and the wet tenacity of viscose is lower. And why is that? One of the reasons of course we can think is the cotton basically is highly crystalline, but then why should the tenacity increase further? Viscose is crystalline to the lesser extent. Why the tenacity changes here? Wetting process basically means some of the hydrogen bonds, intermolecular hydrogen bonds have broken in the wet condition. So, theoretically everything should become weak. but the cotton becomes stronger, the viscose becomes weaker. Interesting. And so, how does one explain all this? This is the paradox. So, one scientist known as Rebenfeld had proposed a hypothesis. If we plot crosslink density on one side and measure the strength, so it does not follow the normal logical sequence, it goes through a maximum. That is, initially when you increase the crosslink density, the strength increases, but beyond a certain value it may start decreasing. In this term called the crosslink density, any type of, he has assumed any type of intermolecular forces, including hydrogen bonds, including crystalline regions, including covalent crosslinks, everything which does a resistance, offers a resistance to movement of molecules was considered as a crosslink density, not necessarily only covalent, right. So, overall intermolecular bondings and forces that you have together, if you put them and then try to plot. And what was proposed and hypothesized was the cotton lies on this side of the curve, the viscose lies on this side of the curve. Why? Because I said, if we consider intermolecular crystallites which are there, which also resist any movement, are like crosslinks, those are very high in cotton. You remember, it's more than 2/3 of cotton is crystalline versus 35 to 40% crystallinity in viscose, depending upon what you do to it. It's a man-made or a manufactured fiber, so you can manipulate the microstructure. So, what happens if this is true? If this is true, then when you wet, so you are reducing crosslink density because hydrogen bonds are breaking. Hydrogen bonds are breaking. Okay. So, if hydrogen break, the crosslink density goes down. So, according to this curve, viscose strength is going down. In the case of cotton, if wetting takes place, this phenomena will still be true, that hydrogen bonds break. They will break in the case of cotton as well. They will break in the case of cotton as well. So, say because it was lying already on this side with too much of crystallinity already there, and so its strength increases. This is the phenomena people had already seen in mechanical processing. Now, when we introduce more covalent bonds, then what happens? We are now increasing the crosslink density. So, we are going in this direction. So, one has seen that if you go in this direction, then the crosslink density increases, the tenacity or tensile strength will increase in the case of viscose. Same thing when happens in the case of cotton, the crosslink density increases, but the strength goes down. So, this is the hypothesis proposed by Rebenfield. Because cotton is already highly cross-linked, because of its crystallinity, if you want to break any molecule free, the molecules are going through the crystalline portions, very difficult to remove, break, because you have to then break the molecule. Its resistance is offered. So, that is like a cross-link density. So, this is how we remember, we define. So, it is already so much crystalline, therefore, putting in more covalent bonds does not really help. Why is that so? It should always help. Important thing is that absolute amorphous system if you have, and if you put cross links, first diffusion can take place better, second uniform distribution of the cross links will be there. And when you actually put load, the load distribution among the molecules is going to be uniform. All the molecules will share approximately similar amount of load, and if everyone is together, the total strength is more. If this happens because of high cross link density which exists already, high crystallinity which exists already, you may not be able to diffuse the molecule as uniformly as you would have loved to do that, and so there may be some reason for believing that there are non-uniform cross-linking takes place at the molecular level, and when you subject to tensile load, some molecules may have to bear or share more load than the others. If they have approximately similar kind of strength, the ones which bear more load will break first, and once they break, obviously the whole chain starts. So, this is the reason why the cross-linking itself in some cases can reduce the strength. So, you have the tensile strength reduces or increases after application. This question obviously is answered, would reduce. For sure, in the case of cotton, right, because there can be losses due to heat, there can be losses due to acid, and of course, cross-linking itself. In the case of viscose, thermal losses, acid losses, if they are there, they will be there. However, cross-linking can increase the strength. So, it's a difficult question to answer, all right. So, what we will do? We would like to optimize in a manner that the losses due to heat and the losses due to acids are as less as possible, so that whatever then happens, happens because of cross-linking itself. So, due to heat there can be losses, due to acids there will be losses if you do not control, but due to cross-linking in both the fibers, both types of fibers, or wherever the crystallinity is less, the behavior will be different than, let us say, cotton. Finally, let us look at another property which we call as an abrasion resistance. Abrasion resistance in textile is measured as a flat abrasion, like you rub surfaces, or a flex abrasion, like a bending. You bend like this, the fabric bends over itself and then abrades, or the edge abrasion, which is like in collars, and cuffs. So, this is the way the people measure the abrasion. So, that is how you can try to check out which kind of a methods people use, actual testing methods, how they are measured. What will happen to this abrasion or any abrasion resistance after cross-linking? Will it increase abrasion resistance because we have put some cross-links, or will it reduce? If tensile strength has reduced, abrasion resistance will also reduce because degradation has taken place. As far as the cross-linking is concerned, you can appreciate anything which becomes stiff is likely to be abraded more, because the abrading surface obviously is much more resistant and much more stronger compared to the textile. And if textile wants to resist more, instead of becoming flexible, it is rigid, it is more stiff, then the abrasion resistance will go down. So, in some way we believe that crease recovery will improve, we are happy, durable pressing, durable press rating would improve, we are happy about it, but some of the other properties are going in the negative direction. So, whenever somebody says, well, 1 plus 2 down, nevertheless, if my aim is to produce a crease resistant fabric, this finish is going to do your job. So, what have we learned? We have learned that the pad dry cure is a preferred process. Crease recovery increases as a result of cross linking. Rebenfield hypothesis talks about how cotton and viscose behave differently and why. Tensile strength generally will go down unless a case of viscose where you optimize correctly. Stiffness would increase and abrasion resistance will decrease. Resistance would decrease. So, you can go to your lab, check your manuals to find out how crease recovery testing is done, how tensile testing is done, abrasion tests are measured, or even bending length, etc. So, you have some first hand knowledge of how these tests are performed, and you may then correlate as to why whatever we talked about is true. We stop here today. Thank you.